Hey, Bert with Anderillium Ink here. What I have is a bottle of Pompadour Cotinga Burgundy ink. This is one of our colors in our avian series. And one of the things I've found very interesting about going to pen shows and sitting with people as they try our inks is hearing how big of a difference some people see colors as compared to others. They might sit right next to their spouse or sibling or friend, and one of them sees a color as a brown or a red, or the other one sees it as a purple or a burgundy. This color here has a lot of contention. A lot of people disagree about what color this really is. If you've ever found yourself in a position where you have disagreed with your significant other over the color that you've painted your kitchen, or what color shirt looks best with what color pants, or etc., there might be a pretty interesting reason. And let's start by asking what seems like a very simple question: what is a color? Well, even though that's a simple question, it has a very complicated answer. A simple answer, maybe one that your science teacher would give, is it's simply the frequency of the wavelengths of light that are reaching your eyes. And we've seen posters of uh, the color spectra, all the rainbow, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, and you can quantize all of those colors into numerical values, frequencies of light. But that only gives those seven colors, or all the divisions between them. It's only seven because Isaac Newton had some, he called it seven colors. If you ask in other cultures, they have other numbers of how many colors are in the rainbow. But as small of a subdivision as you can make, that's every color is represented by one number, a frequency of light. And that's an incomplete way of looking at color. If we were to ask the question, what color is a grizzly bear, we would almost universally get the answer brown. And brown doesn't appear anywhere in Roy G. Biv. There's no slot in the rainbow for the color brown. So, what would the frequency of light of the color brown be? Well, it turns out, and you might think, it's just really dark orange. That's not true, because I could have an orange flashlight, and if I made it dimmer, it would never dim to the point where it's brown. Orange and brown are different things. And it turns out brown is not what's called a spectral color, a spectral color being just colors represented by one frequency of light, the spectrum of colors or the rainbow colors. Brown is a composite color. It necessarily has to be made of more than one color. Now, I work with dyes and inks, and mixing colors, we know that you can add blue and yellow to get green, for example. Can we just start out with green? Green could be a spectral color. But if I took blue and yellow and added it and got green, I could get a color that looks very similar to that spectral color of green. Would it be the same? And the answer is no, it wouldn't. Even if it looks almost indistinguishable to your eye, it might actually look different to someone else. And I'm going to use a metaphor here. I'm going to use a musical metaphor. The way our eyes see color, when we have multiple frequencies occurring at the same time, multiple frequencies in music we hear separately. So if we have two different frequencies, let's say a G and a B, we have two separate frequencies. I could play them together, and that sounds to our ear distinct from what would be halfway between them, right? This note here. This, we hear differently than this. But visually, we don't see colors the same way. So if I take yellow and blue and I play both of those notes together, we will see only the color in between those. We won't see them as separately yellow and blue. Sorta. Sorta. We all have physiologic differences, anatomical differences in every aspect of every part of our body, including our eyes, including the photoreceptors that moderate incoming light, including the way our brains process that. And I might see blue a little brighter or a little less bright than you, and you might see yellow a little brighter or a little less bright, or it might seem a little warmer or a little cooler. It might have different characteristics to you than to me. Now, if I make a color green that is made from blue and yellow, and one person sees blue slightly different, that spectral blue slightly different, then than the person sitting next to them, that color green will also appear slightly different. And the more complicated and rich that composite color, like Pompadour, Cotinga, Burgundy, the more controversial it can seem when you look at it. The more varied it might look under different colors of light, if you're under fluorescent lights or LED lights or daylight, or two different people looking at it might appear quite different. So the question, what is a color? Everyone would look at a swatch of any given ink on paper and agree that that is a color. That's a color of ink. In reality, it's a lot more complicated. It's a lot more rich. It's more like cooking, right? There's lots of ingredients that go into a given flavor. So you might be tasting some dish that has a complicated palette of flavors that are contributing to it. Is the same way you can see what appears at first glance to be one color of ink might actually be a complicated palette of colors that are all contributing to make a composite color. That's why and how we can have different experiences as individuals looking at one given color. I hope you found this interesting. I'm going to do some more videos on color theory coming up, so stay tuned and keep your eyes out for that.